Right. So if you, okay, yes, Srinivas, go ahead. Uh, yeah, you can drop me an email with the email ID I have mentioned, as well as you can connect me on this Skype ID. So let me just, so this is my Skype ID. I'll just type it for everyone. Let me resume. Okay. So this I will have my Skype ID shared with all of you. Though I'm not very active on this Skype, so I'll not be there online most of the time. But you can drop me an email. The email address I have already shared yesterday. Okay? Or let me share with everyone on the Skype ID. Okay, fine. So let's get started. I think if people don't have any questions, I will start on my session. Though I uh, would like to have it interactive session. So what the plan and agenda would be to I'll start on the session, and every logical when the class meets a logical closure, I'll try to ask couple of questions. Okay, so that you guys are active or not, I will check it out. Okay, and also your concepts are not clear, I will we will get clarify those concepts, right? All the recordings would be available on my drive. Okay, the same drive where the virtual machine is available. Okay, 1 second, guys. Okay, so those of you were following up yesterday for the recording sessions and the virtual machine. Okay, so for everyone, if you have taken a training with us, or if you are enrolled for the course, you should all be having access to this drive. There are a couple of people who have got access to this drive, if you can see over here. Okay, and I have added people who have taken the training and who don't have access to this drive. Okay, so there is the training class of yesterday is available over here. Okay, you can download it into your machine. Okay, right? And today's session also I'll try to push it by end of day. Uh, Wherever I actually have to convert the recording into MP4 and then and upload it, so it might take some time. Otherwise, I will just upload whatever the existing recording you have. Share me download link. Okay. So Vasu, if you have registered for the course, you can drop an email to us, and we will be able to share this link with you. Okay, fine. Okay, so let's get started. So for today, what I wanted to cover as part of the agenda is we left on where the on one of the characteristics of the big data, right? We just talk about that if it is beyond a certain volume, okay, which is nearly about 1 petabytes to and above, okay, we said that it logically falls into a big data. Okay. So what are the other two characteristics, right? So yesterday we spoke about other two characteristics like velocity and the variety of the data, right? So we'll quickly touch upon that. What is that variety of a data? Uh, and then we'll talk about the velocity too. Okay. So just imagine a traditional RDBMS system, okay? Anything like a SQL server, okay, or Oracle server, or any RDBMS system like MySQL server. Okay, if you see a table structure, okay, into this databases, you will have a table where you have a column, and this column will have a data, and you have to define what kind of data it can contain, and that is called a schema. Okay, so say for example I have an employee table. I will have my employee first name, last name, and the employee ID, and then I will have a schema around it. If it is an employee ID, okay, it would be something called an integer. Okay, if it is employee name, it can be a varchar. Okay, and then I can define what can be the length of a varchar, right? Again, if it is a salary, I can define it as a float. Okay, so you basically define your structure, or you define the schema for a table, and all the data that gets inserted into this structure, okay, is tightly integrated with the structure. Okay, so say for example, if I have to load a data, any loading mechanism I have to do into this database, okay, it has to follow this schema. Otherwise, what will happen? The database will reject those data, right? And what will happen if you're passing in place of integer, if you have employee ID which is something like this? Okay, so I will say Vasu and 20001. Okay, so if this is the employee ID for the Vasu, okay, and it will it accept, will the record get accepted by this table? Okay, fine. Yeah, the record won't get accepted, and what will happen? It will reject out the record. Okay, yeah, correct. Because it is an integer, so what RDBMS system will do, it will reject out this record, and then you will see something in the output saying that failed to insert this record for so and so reason. Okay, and similarly, if you take any column, right? So any column, if the data type is not matching and it is not compatible, or the conversion is not happening, okay, sometime it does the automatic conversion, but sometime it is not able to do that. Okay, so if it is not able to do it, you will have a lot of rejected data, right? So that is the one problem with the RDBMS system. The another problem is, say for example, your data has grown, okay, and the volume of the data has grown to as we were talking about, in hundreds of GB. Okay, so now what will happen, if you think something, that this employee table should also have one more column called location. Okay, so most of the time you might have come up with this case that the schema of a table is getting changed, and there are multiple columns that are getting added. Yeah. So what will happen now? If I have to add or alter this table which is having 100 GB of a data, and if I have to add a column location, what will happen? Okay, in a typical production environment, okay, what it will happen, they will say, your DBAs will say, I need 2 to 3 days of downtime. Okay, and that is the amount of impact, the business impact will happen. Okay, because the altering of a table is basically is very difficult, and if you are if you go into production environment, and if you talk to any DBase, he will shout at you if you are doing in a very huge database size. Okay, and if you are just talking about one column, if you are talking about multiple columns and then inserting the data into that and all, you might as well think about a weeks of downtime. Okay, so what happened is that you have to be very thoughtful when you are designing the system. Okay, because of this two constraint. And all of the business systems which developed around 1990 to 2000, okay, most of the business application knows what data they need, what is the data type, what data is coming, okay, and they have full control on the business, so they could define this kind of integrated or a tightly coupled data structure, or which we'll call a database in and a table into that. Are you guys with me till now? Okay, okay, fine. But what happened after 2000 and all, right? So 2000 and beyond 2000, okay, what really happened? Okay, so with the advent of social media websites and like websites like Twitter, Facebook and all, what really has changed? Okay, if you imagine a Facebook or a LinkedIn or a Twitter, the data cannot be, it does not follow any particular a particular schema. Okay, you can write anything if you're writing a post, okay, or if you're writing a tweet. Okay, you can write anything. You can have a alphanumeric character. You can write something which is a character. You can write a float, right? You can have anything in the tweet. Okay, you can have a special character and so on and so forth, right? So you cannot really define a structure like this which is tightly integrated. Okay. Similarly, if you see the Facebook post, you can write anything. The length of the post is not. Do you think the post length you can determine? You can write anything. Okay, it really does not restricts you to say that your post cannot be beyond a certain number of characters. Okay, then you can tag your friends, right? And you can update, people can update and so on and so forth, right? So this structure, the tightly coupled structure, is not valid for this type of application. Similarly, the application gets frequent changes. Okay, the because since it's a social media website, okay, people recommend many changes because all your application is designed by what the user needs, right? Most of you will agree that whatever the user needs, you will design your system based on that. Okay, and this type of system this people are using on the social media, okay, they will need lot of things. They will say, okay, I wanted to tag a friend, I wanted to hashtag. Okay, so most of you might be using an hashtag into the Facebook, right? Then somebody might be saying that I can upload a photo, I can share a photo and so on and so forth, right? I can add a games, okay, favorite games, more applications and so on. So this applications are changing very frequently also, right? Because this is utilized by multiple users. So the changes in the structure of application is very frequent. Okay, it is not like a traditional business application where the changes would be very minimum. Okay, this type of business, social media and networking and all, the changes are very frequent, so that your schema should be flexible enough and you cannot have your, imagine Facebook saying that I need a 2 to 3 days of downtime because of so and so reason. Will people ever come to Facebook? They will not. Okay, they will never imagine their website saying that if it is down for 2 or 3 days. Okay, so the two challenges what I'm talking about, right? So because of this, the variety of data that gets pushed into the that is getting generated because of multiple applications, right? that uh, that variety is not been handled, cannot was not so easily handled by a traditional RDBMS system, and then there was a need to focus on something for a solution space. And people were thinking about a solution, and somewhere later they found out a solution in the Hadoop. Okay, so we'll talk about the solution now. Okay, let me quickly bring up the PDF or the slides what I have. Oops, I think there's something wrong. Okay. Okay. So we talked about the volume, I talked about the variety of the data. Okay. We'll talk about the velocity, but I would like to take a quick pause and then just check it out whether you guys are all with me. Okay. So are you guys all with me? Can I have some questions for you? Okay, fine. So let's have a quick question. Okay. So you all have worked with multiple applications, right? So you might have worked with a CRM application, SAP application, right? You might have worked with web applications and all, right? And you have also worked with applications like Word, emails and all, okay? So if you have to say whether the data into these files, okay, and data stored in these files are structured or unstructured, how do you define that? Does XML have a structured data? Structure is something which RDBMS follows, right? So tightly coupled structure. So does XML has a structure? Okay. Anybody? Okay, Vijay is saying yes. Okay. How about Word docs? Ashwini is saying no. Okay. Vijay is okay. For Word documents, okay, no. Email body, okay. How about data from enterprise system like CRM and ERP system? Do they have a structure? Okay, perfect. Yeah. So yes. So what we were, most of you are correct. Okay. So XML file. Okay, we have to think about the XML file over here, right? So once you see a XML file, right? XML file does have a structure. Okay. So if you imagine a XML file will start with certain tags. Okay. And okay, you will have a tag something like this, and you can write anything in the tag. Okay. So you really have a, if I have to define it into a hierarchical terms, I can say this is my bookstore, okay, and this bookstore ID and so on and so forth. Then I can write this book one, okay, and this is a book two, right, and then finally I can close on the tag of the bookstore, right. So this is a typical XML looks like, right, and you can have a multiple hierarchies and all, so that is a different issue altogether, right. So you have a structure, okay, but that structure is not a tightly coupled structure, right. The reason I'm saying is the book one, okay, you can write anything, you really don't have any limit on what the length of the book would be, okay. You really don't have any constraint on whether the book name can contain alphanumeric character, okay. Say for example, I can say 10 best things in life, right. So I'm saying 10 can be a number, right. So this is what I can store in my book, okay. And I can go as long as the book name is right. So there is really no constraint which I can define, okay. I can have a application name, and I can say, okay, I can take another example where I can say I have in my XML I have stored the application names, okay, and the various sub application that are working or are the subset of the main application, right. And then again we can say, okay, this application is so and so, okay, and the sub application has so and so name and all, right? So it is a structure, but at the same time it is not a very constrained structure like a RDBMS system, which we say a CRM system or a ERP system. And that is the reason something this is XML is called a semi structure. Okay, right? And whereas if we take a example of Word file and email body, those are totally unstructured. Okay, and that is why they are called as a unstructured data. Okay, and as we mentioned, the very first thing about the enterprise system, those are structured data. Okay, so typically your big data will have all these three kinds of data to deal with. Okay, whereas the traditional RDBMS system are good at structured data and the semi-structured data, they find a lot of challenges when it comes to the unstructured data. Okay, are you all guys with me now? Okay, fine. So let's go ahead. Let's move on. Okay. So the last thing I wanted to cover is the velocity. Okay, so I will park the velocity for now. Okay, and once we come to the right juncture, I will cover this part. Okay, so what is the typical use cases what we use in a big? Am I still audible to all of you? So there was a power cut, so I was having some issues with the power cut. Okay. So there are some of the use cases in a typical big data problem. Okay, we will talk about this use case later. Okay, so let's go ahead and see that. Okay, right. So this is a typical application or when you move a data from the source system to the target system. Okay, this is how typically the data flow looks like. Okay. If you have not worked with the data warehousing solution, so might be you have to put some focus over here. People from a data warehousing background might know about this. Okay, so this is my storage. Okay, uh, this is storage is a centralized storage. Maybe it's a database or if it is a mainframe database or whatever it is. Okay, and this will contain data about your application, whatever application which you are dealing with, and it can have you can have multiple such databases. Okay, if you have one application and then you can have multiple applications from where you can read the entire data set. Okay, so what happens since data set is more that the storage is more where you store the data, right? Before you move that data into uh, you move it through the ETL process and then put it over here. Okay, so if we are talking about a typical data warehousing application, right? So yesterday I showed you a very simple example. Okay, where I said I have a two applications. So let's consider as this as a three different application. Okay, And if you have to do analysis across the application, you have to pull the data from this three application into a central storage, right? And this happens through the process what we call a ETL process. Okay, right? So what happens, why we are talking about this again, once again, revisiting this once again. So just imagine the size of this database, okay? And just imagine the size of these three databases, okay? If this databases, the individual sizes of this database is around 200 GB, okay? Right? Each I am saying is around 200 GB. And if you have to move this entire data set, right, across or move into a centralized store, okay, that is our data warehouse, okay. So what will be the couple of challenges which you'll have, right? The very first challenges would be, what is the capacity of the disk I should have, right? So the disk capacity should be able to handle the 600 GB of data, okay? Or this is a very small number, okay? Just imagine if you have 10 different systems, okay? Again, everything is around 200 GB of a data, and all of them are pushing it into a central storage, okay? What will happen? You'll have now 1.2 TB of a data, and if it goes on like this for some time, you will, and if you have multiple system which is pushing which you need to accumulate the data into a warehouse, okay, imagine the size, the capacity of the disk you would be needing, okay. So this capacity is not so or you need to go for a higher disk storage, okay. That would be your first challenge, okay. You need to so the storage is something like this, right? So if you go for a higher storage, the cost of the storage goes exponentially increases in the cost, okay. So the cost factor is one of the challenge when you go for a higher disk capacity, okay. The second thing is you would not only would like to store this data, right? So if I have only to store this data, it would have been easier to just to go and buy a disk and do that, right? But I need to read from the data, okay? Why do I need to read from the data? Because I have to read the data to understand what the data is. I need to do certain more processing, okay, before I put it onto my reporting structure, right? So when you start reading from a disk, okay, or whenever we start reading from a disk, okay, the challenge would be the speed or the rate at which the data is getting transferred, okay. With the very sophisticated disk is not more than 100 Mbps per second, okay, and it is a megabit per second, okay. This is, I'm talking about a very sophisticated disk which we are talking about, okay. Now you imagine the amount of data what we have around 1.2 terabyte of a data, okay, and 1.2 terabyte is almost 1.2 into 10 raised to power, okay. So when we are talking about let's take an example of 100 gigs of data only, right? In order to read this 100 gigs of data with this speed, how long will it take? I need to first convert this 100 GB, okay, into MB, right? So this is how I convert GBs into MB, right? Then I divide it by 100, okay? And this is the amount of seconds, so it would be like 1000 seconds, right? And if you convert the 1000 seconds, how long will it take? Okay. And also one more thing you need to remember, this is bits, okay, not bytes, okay? So you have to again multiply it by 8, okay? Or we can multiply, one bit is equal to, 1 byte is equal to 8 bits, right? That is what the number is. We can, for our simplicity, let's take it as a 10, okay. So what we are talking about is 10,000 seconds, okay, and 10,000 seconds is roughly converts to around 2.5 hours, okay. If you try to do this calculation, okay, it will come to around 2.5 hours just to read this data, okay. if we have this amount of a data what we are talking about. Okay, so reading this amount of data is going to take 2 to 3 hours of a time. Okay, and imagine if you have a data which is around 200 and so on and so forth. If it's 200 GB, you will take 5 hours roughly, right? So these are the two key challenges when we are talking about and when we are talking about the analysis and the storage of a data. Are you guys all with me till now? Okay, fine. The reason why we are talking about all this is the challenges which we are having. Okay, so now let's quickly jump to the solution space. Okay, are you guys all okay with the speed I am going? Okay. So you guys can stop me and tell me if I am going into more details or if I'm going too slow or if I'm going too fast. Okay. Right. So as I mentioned, the storage challenges, okay. Then the processing challenge, the rate at which we read the data, okay. Because this data has to be then used by your reporting solution to visualize the data, right? So this were the three key challenges, because the reporting also you need to see when you are pulling a very huge amount of a data, you need to have a very sophisticated software over here which can read everything from the database, okay, or which can have its own database, store all the data what it is required from a reporting perspective, so that the reports generated are very fast. Okay, right. So how does the ecosystem changes when we are going into the Hadoop? Okay, so first thing, let's see how the ecosystem looks like when we are not into the Hadoop, right? So this is still a data warehousing solution. So I might have, as I said, I have multiple applications. Okay, all these are OLTP application, and they all are having the OLTP database. Okay, or let's say this is a single application. Okay, since we have only single database, so let's say this is a single application and people are accessing the application. Then you have a social application, and then you have a logs which are generated. So this is something an XML file, or it can be a flat file. Okay, so heterogeneous data sources, right? So this is what we call as a heterogeneous data sources. When we will be talking about big data, we'll be talking about, or in a data warehouse we'll always talk about heterogeneous data sources, right? So this is a RDBMS system, this is my XML or Excel file, or it can be a flat file, and similarly for this. And all of this, the data gets moved, okay, into a central storage, which is very expensive, which I have just shown it to you, okay? Because you need to read the data for multiple purpose, right? So you need to process the data, so for that you need to store, you need to read it faster, okay? And then you can have a reporting structure based on that, okay, right? So when the Hadoop came into the picture, what exactly got changed? Okay, so how does the architecture looks like, or how does are you guys able to hear me? Okay, so this is how traditional systems or a simple data warehouse application looks like, okay? So now once we come to the Hadoop space, what has changed is this, okay? With Hadoop coming into the picture, the storage is now moved and changed through the Hadoop. Okay, so the if you want to compare it with the previous slide, okay, you say this expensive storage. Now we have, in place of expensive storage, we'll now have a Hadoop. Okay, and you can generate a report directly from the Hadoop. Okay, and also you can move the data from Hadoop to any data warehouse database. Okay, or which we'll call it as a data mart. Data mart are nothing but a subset of a data warehouse. Okay, that is a data mart. Okay, uh, people who have not from the data warehouse background, just remember this. Okay, so you can put a part of a data, okay, whichever is, say for example, in my storage there are multiple data which is coming from a different sort of applications, like say for example I have a shares application, I have a loan application, okay, and I might have any other application like financial planning application. Okay, so these are my all different OLTP systems. Okay, and all of this data is coming into the storage. I want only to visualize the data based on one of this data set based on one of this application. Maybe I wanted to just visualize the loan application data. Okay, I can move that data because that would be different business users, and put it into a data warehouse or a data mart, and then I can generate a report based on that. And the other reports I can still generate directly from the Hadoop. Okay, so this Hadoop came into the picture. Okay, so now we will talk about couple of more challenges. Okay, then we will jump into the solution space. Okay, and we will talk then about the Hadoop, and also we will start our cluster and do certain commands into the Hadoop. Okay, the one of the thing, because we are going into a conceptual thing, very important is once you guys go into the hands-on and practical, okay, it is Hadoop is like cloud. Okay, so what do you mean by cloud? Okay, so cloud has three parts, right? So try to understand this. You can have infrastructure as a cloud. Okay, so when we are talking about software as a services, so that is a SaaS. Infrastructure as a services, IaaS, right? So you have to understand what we are talking about when you're talking about the cloud, right? Yes, we can deploy our Hadoop on the cloud. Okay, that is what it is. Because if you think about this on the cloud space, okay, you can have anything called any servers. Okay, I can have multiple web servers, okay, on the cloud. That can be my Ubuntu machine, okay, and I on all of this machine I can have a VM installed, or a Hadoop installed on each of them, and I can have Hadoop on the cloud. Okay, though I can have Hadoop on my physical boxes also, right? And all of this will be a part of a cluster. We'll talk about it, okay, but just remember this, guys. Okay, when we're talking about the cloud, okay, we have to just understand this part also. Are we talking about infrastructure? Are we talking about the services in the cloud? What exactly we are talking about? Okay, okay, fine. So let's come back. So what typically the traditional solutions for this type of problem? So when we were talking about higher storage, okay, uh, what were the solution that traditionally it was we were looking into? Okay, so if you imagine if you are from 2000 or before that, okay, people used to work on a 512 MB RAM, okay, and a 2 core machine, okay, maybe a 1 core or a 2 core machine, right? Now if you imagine right now we are all working with around minimum 4 GB RAM, okay, or maybe a 8 GB RAM, right? And also the processing power or the CPU, right? So CPUs would be around dual quad core, that is nothing but your 8 core machine, okay, or even if it is a quad core machine, it is a single quad core, then it's a 4 core machine, right? So initially when people were looking for very huge data size, okay, and they wanted to read this data and process this data, they were looking into increasing the RAM in a machine and increasing the CPU in a machine. If I had to make my machine faster, these are the two approaches, right? Either I can increase my RAM or I can increase my CPU processing, okay, and this is something called vertical scaling up of your system, okay. You can go from 2 GB to 4 GB RAM to 8 GB RAM to 16 GB RAM to 32 GB RAM, and if you take in a production, it would be a 64 GB RAM. Okay, most of your production system would be in this range. Okay, and the CPU will also be 8 core or a 16 core machine, right? We cannot go beyond this into a vertical scaling. Okay, what is the reason why we can't go beyond this? Any idea, guys? Why cannot you go with your desktop or a laptop which is having this kind of RAM and this kind of CPU? Okay. So apart from the architectural reason, anybody, have you ever gone and bought a 64 GB RAM? Okay, go to any store, okay, and say I want a 64 GB RAM and 16 core machine. Okay. If you go to any store and say I want this kind of machine, okay, he will say, boss, it would be roughly in range of 1.5 lakhs to 2 lakhs, okay, or more than that. Okay, and they would not have a beyond 16 cores. Okay, the reason being the amount of heat which is getting generated because of the CPU, okay, that cannot be handled. If you go beyond this, you need to put all your machine, or if you see, all your server machines are highly centralized AC, right? Because the amount of heat they generate is very huge, and you have to make this system cool. So if you buy this kind of a laptop or a desktop, you need to buy another AC and make it 24 hours up and running to work with this kind of system. That is the reason all your data centers and all are very centralized. It is a AC room and all, right? So the very first thing what I'm talking about is a costing factor, right? If you go keep on increasing into a RAM and the CPU processing, the cost will become very high. Second thing is the hit will generate will not be you'll not be able to control it, or it cannot go beyond a certain capacity on a single machine, what we are talking about now. Okay, and when you increase this resources on a single machine, it is called a vertical scaling up. Okay, that is what we'll call a vertical scaling. Okay. Yes, yes, Rajan. Okay. So the next solution for this time of problem was thought. Okay. What Rajan is also mentioning, you can go with the horizontal scaling up. Okay. So people went with that. Okay. So they went into horizontal scaling. Okay. They said, okay, this is my central storage. I cannot really distribute my storage, but I can have a CPU processing power. Okay. I can have multiple CPUs. Okay, this is my first machine, second machine, third machine, and fourth machine. Okay, and they will process the data, take the data from here, process it, and then store the results back. Okay, so it will send the result back, and then it will take a fresh copy of a data and then start processing, right? So you can have this machines as I can say 8 GB machine, and now you can have a 8 GB machine. Okay. Right? And that is the solution what we also call as a distributed computing, right? So some of you might have heard about it, the distributed computing. Okay, right? So one of the challenge with the distributed computing with this kind of architecture is what happen if one of my machine goes down. Okay, what happens if it has processed 50% of a data and now it has failed. Okay, so those type of challenges were available when we were going with the distributed computing, because you really cannot define the state this machine is there. Okay, or you can only say whether it is up and down. You cannot really say whether it is a 50% processed data okay, or it is a 25% process data, or it is a 10% process data. Okay, if you have to do this, you have to program it in a way that after every processing of 10%, it will send out the results back or send out the results into certain cache. Okay, so that you can recover it when this machine goes down. Okay, so all this kind of challenges were there with the distributed computing, and this will all has to be dealt by a programmer. Okay, and that is where the complexity of programming was very difficult into a distributed computing. Okay, and because of these two challenges, okay, because of what challenges we talked about in a distributed computing and vertical scaling up, the solution emerged, and that solution is called a Hadoop. Okay, and Hadoop solves both of these problems. Okay, we will check into Hadoop. Okay, now that how it solves this kind of problem. Okay, and then we'll get started with the Hadoop. You guys with me till now? Okay, so guys, since we have started the class 10 minutes late, is it okay if I continue the class till 8:40 or 8:45? Is it okay with all of you? A quick acknowledgement from all of you will help. Okay, 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 fine. So let's continue this. Okay, so how does the Hadoop solve this problem? Okay, so Hadoop as application, sorry, the definition from wiki. Okay, so what is a Hadoop? Hadoop is a distributed, okay, and a distributed library which will help you to do two main things. Okay, one thing is, okay, it will, if your system is failed, okay, it will help you to basically know the state where the failure has occurred. Okay, and it will also help you to scale up your system. Okay, so it helps you with a scaling up. Okay, you can add multiple systems into the Hadoop. So in a Hadoop cluster, you typically will find around 40 or 50 system into your Hadoop cluster. Okay, multiple systems into your Hadoop cluster. Okay, and also what happens if one of the node or one of the machine goes down in a Hadoop cluster, it will have a copy on some other nodes or some other machine. Okay, and this has not to be taken care from a developer point of view. What we were seeing as a problem is space when we were talking about a distributed computing. The library itself take care of that. The Hadoop library itself takes care of if a system is down, it will switch the task into a adjacent system or a nearby system. Okay, and will start the processing from there onwards. Okay, so let me quickly take the definition. Okay, so as the definition says, okay, so it's a software library is a framework. As I mentioned, it's a framework. Okay, and it provides distributed processing of large data sets. Okay, so that is what we were talking about. Okay, the second thing is a scalable solution. Okay, it you can really scale up from one server to thousands of machines. Okay, so one of the thing which we have to take care, also remember over this in the definition is it is a local computation. Okay, we will come into the local computation. Okay, but very important, the local computation part. Okay, because when we were seeing the distributed computing, the storage was a centralized storage. Okay, and the data was being moved into the multi, this was the storage. Okay, this is my storage. Okay, and the data was moved across the storage. So it was having, it was posing a challenge because of the bandwidth utilization. The data has to literally move here. Okay, and then the processing has to happen. But with when Hadoop came into the picture, it provides a local computation as well as the storage. Okay, so very important thing. Okay, so your storage will also be here and your computation will also be here. Okay, we will see how it is done. Okay, and then it is said it rely on a hardware to deliver the high availability. Okay, it is basically a software driven library which will handle the high availability. So most of you, some of you have done a high availability testing. Any of you have done the high availability testing? Okay. Yeah, perfect. Okay. So I can see couple of yes. Okay. So high availability, right? So how do you do? If you have in a production some databases, you do a clustering. Okay. So you have two cluster or the two databases. Okay. Right, and then you have a application running over here, and you might have a multiple copy of that application. You can have a web server 1, you can have a web server 2, right? And they will do a lot of testing on the high availability. Once they will say this database is down, okay, it is the same copy of a database. Okay, so the DB is the same copy, so I will say DB copy 1. Okay, and this is database copy 2. Okay, it's the same copy. Okay, so and but we have a two different web servers, and on the first instance both the web servers are pointing to this database and then serving the request. Okay, and suddenly this database goes down. Okay, now this database goes down, the switching has to happen programmatically or through some mechanism. There are a couple of tools, okay, which will help you. Also you need to handle it programmatically, that all the requests from both the servers should automatically go over here. Okay, and there has to be synchronization too, because you cannot have these two databases cannot be out of sync, right? So all this has to be taken care, and people have to program it separately for their high availability testing. But with Hadoop coming into the picture, the Hadoop library itself take care. Okay, is designed to detect and handle the failure. Okay, and delivering a high available service on top of the cluster of computer. Okay. So this is the Hadoop, basically a definition, and there are a couple of key points which will be dealing into the next slides. Okay, right. So very first thing which, okay. Now, since we were having a challenge with reading speed, right? So we talked about that if we are reading a data which is 100 GB data, okay, with the speed of 100 megabit per second, okay, it was taking almost for us 2 hours, right? 2.5 hours through a single machine. Now if I increase my machine to 4, okay, how much time will it take? You have to divide it, and you can see it will be divided by 4 and the amount of time. And if you make it as a 10 machine, again it would be 0.25 hours, right? And it would be roughly, if you have a 10 machines over here, the entire data set you can read it into 15 to 20 minutes, right? If you have a 10 machines. Okay, if you are parallelly reading a data, okay, if your data is divided something like this, okay, my 100 GB of data was now is not on a one machine, now it is on a 10 machines. Okay, and I am reading all the data simultaneously from this 10 machine. What will happen? The total data which will be read would be in less than 20 minutes. Okay, so this is what one of the concept of Hadoop is. Hadoop whenever you are trying to store a file, say for example, okay, in a layman terms, if I have a file, okay, the file name I'll say wisdom.txt. Okay, if I have a file called wisdom.txt and it is a 100 GB file, okay, the one while it is storing, it will store into it will first divide the data, okay, into multiple files. Okay, in terminology of Hadoop, that is called as a blocks. Okay, okay, so this is my block. Okay, and this is again my block. Okay, and this is again my block. So my entire file, any file, if I have a very big file like wisdom.txt, the entire file will be divided into multiple blocks. Okay, and that blocks would be would be stored into the different machines. Okay, okay. And the entire data, since it is now distributed across multiple machines, okay, the reading would be much faster. Okay, so that is what this says, that distributed file system, that is Hadoop provides. This is called a distributed file system. The file is distributed, that is why it is called a distributed file system. And Hadoop, in Hadoop terminology, it is called HDFS, which stands for Hadoop Distributed File System. Okay, are you guys with me? Okay, we'll finish in next 5 minutes. What happens if the data blocks get, okay, 1 second. So there is a question. Okay, let's take up the questions. We have 5 more minutes, so I'll be happy to take the questions now. What happens if the data, okay, so let's take one by one. So first question is from Rajan. Rajan is asking, what happens if the data blocks get stored in the same machine? Then the reading would take some good time. Does Hadoop redistributes or move the data to different machine? Okay, fine. So that is the another concept of Hadoop that I will be talking about. Okay, Rajan. So it is not only the blocks. Okay, this block is available here. Okay, so what happens if this machine goes down? Okay, your block is not available, then you cannot recreate your file, which is wisdom.txt. Okay, so that should not happen. So what also Hadoop takes care that it not only transfers the blocks over here, but it distributes the data over here also on this block and this block. So even if this blocks, let me take a different color for, so even if this block is not available, the data or the block, okay, is available on this machine and this machine. The replication is across 3 machines by default, though you can change it, change the replication factor. Okay, so that would be one of your quiz question. Okay, sometimes if you are going for any certification exams and all, so people might ask what is the default replication factor, or for an interview people will ask what is the default replication in Hadoop, and that is 3. Okay, so the same data is replicated across 3 different nodes. So next question is from Thomas. If the file is broken into blocks and stored in different system, and if one of the system goes down, what will happen? Okay. So Thomas, I have answered your question also now, right? Because if this is down, it basically had a replica. Okay. I can take few more questions. Okay. Till you guys think about the question, okay, what I will show you today is how to start the cluster. Okay. So I have a cluster. All of you might, I expect everybody might have installed the prerequisites and have seen the video how to start the cluster. Okay, very important, guys. If you have not done it, okay, just see that 5 minutes video and you should be able to start the cluster. All the files are available over here. So I have 9 files. Just download it. You need WinZip 7-zip software because these are the multiple parts. Even all three blocks are down, replication moves to the other block. So all three blocks are down. Are you saying three machines are down, right, Vasu? Okay. So Vasu, yes, we do have the replication factor is 3 by default, but you can always change it. I can make it as a 4 if I think that the highly probability of one of the machine going down is high. I can make my replication factor as 4 and 5. Okay. But again, that will have its own trade-off, and the replication will not happen on the same rack. Okay, if you the Hadoop is intelligent enough. Okay, so if you people are not aware, Teradata has good parallel processing capability in Teradata Hadoop used in conjunction even from data model perspective. Okay, so Rajan, I'll answer your question on the Teradata. Just wait for some time. Okay, but yeah, Teradata is good enough and it provides the parallel processing. Okay. But the only thing, the challenges is you cannot make a cluster as what we are talking about. Okay, it has a parallel processing, but it is within the same machine and it makes its own virtual machines within that same machine in the Teradata. Okay. So what I was talking about, the replication factor, right? So one more thing I want I have to touch base upon it. Okay. So this is my rack. Okay, rack is nothing but your shoe rack. Okay, or any rack in your house. Okay, or any cupboard in your house. Okay, so in a storage terminology, in a rack you can have machines. Okay, so I can have the 5 machines or the 10 machines in the rack. Okay, so just take this 10 machines out of this. I am having 5 machines in rack 1, and these are my another 5 machine in my rack 2. Okay. So how the replication happens is something like this. Okay, it will have a first copy, so block is available here. Okay, the next 2 copies, okay, the this and this copy will not be available on the same rack. Okay, or will not be available on the same machines in the same rack. It will basically move the data. Okay, the copy of this data will be available on an adjacent rack. Okay, so the copy 2 will be available here, and copy 3 again would be available on the same rack. Okay, so if I say this is my block 1, okay, the another copy of a block 1 would be available here as well as here. Okay, so sorry, I'll say all as a block 1. So what will happen, right? Even if this machine is down, it can read from this. Even if this rack is down, okay. So Hadoop is intelligent enough. Even if the entire rack is down, sometimes the entire rack might be down. It can read the data from another rack. That is the reason it copies the data to another rack. Okay, or system on another rack. In a more specific term, systems on another rack. Okay. Fine. So coming back, guys, I was talking about how do I start my cluster. Okay. Uh, if you have access to this drive, most of you, if you have taken our course, you download all these 9 parts. Okay. You need a 7-zip software. Okay. And that software will take care once you unzip it. Okay. And you will have a single file that you can open it in through your Oracle VirtualBox. This is a software required, another software required. Okay. Okay. I don't have it. Okay. And now what I can do, I can open up, I can just say import appliances. Okay. And I need to see where my OVA file is there. Maybe I have my VirtualBox VM. So I have my Wisdom VM over here. Okay. Fine. Right. So I have my Wisdom VM over here. I'll just say open. Okay, and then I can import it and I can start using it. Okay, you can give based on your current configuration in the machine. You can give as the 2 CPU. Okay, you can increase the RAM. I can go beyond a certain capacity. Okay, and I just have to say import. So, and one more thing, the disk image, I don't want it to be put into this drive. I want it to be available into my D drive. Okay. Because my C drive is a lesser capacity. Okay. So Vasu, you have to drop in an email as I mentioned, and Ashish will take care of that, or I'll take care of that. Okay. Anybody will take care of that. Right. So this is a virtual disk image. This will be generated. Okay. Once you download, it will first it will happen. Okay. I don't want to recap what I have already covered on those video. Okay. You just have to do an import and you will start importing it. The virtual machine, it will take some time. Okay. Around 2 to 3 minutes and you will be all good. Okay. Yes, Srinivas, you can send it to both support as well as the other mail ID. Okay. Whatever mail ID you are having it. Okay. So it is taking some time to import. So guys, I think we can close on this session today. Uh, you can watch my video also available over here. Maybe I have a video available over here. Okay. Or you definitely have access to the video how to do that. Okay. I'm going to log in and show it to you. So this is the video link which you can use. Okay, and installation Hadoop. I think. Hi everyone. Welcome to the tutorial on big. I will show you how to change the CPU and RAM in some time. Okay. Okay. So this video you can see and you can set up your VM on your own. Okay. If you have any challenges, tomorrow we can discuss anything. Okay. You have a download VM for Hadoop. You can click over here and you can get download also. Okay. So that's it for the today's session, guys. I would close on this session today and we can meet tomorrow. Yeah, Vasu, this is for lifetime. Okay. Rajan, yeah, we will take care of sending the invite.